All right, so now let's start looking at the substitution method, which is our first algebraic method for finding the intersection of two lines. That's what it means to find the solution of a system, is to find the intersection point of two lines. So take a look at my example here of two different lines. They're not written in any particular form. For instance, it's not written in y equals mx plus b form. Of course, we could write these equations in y equals mx plus b form if we wanted to, but I'm going to give you a hint right now that we don't. We'd like to leave it just the way that it is. So let me write down also substitution, because then as you're looking at this, you'll remember we're talking about the substitution method. When we solve an equation, which we have done in the past, when we have one variable, so let's say we have the variable x. If we want to solve for x, we isolate the variable, and then we get a number of x on one side, a number on the other side, and that is the solution to the equation. The reason that it can look so strange to see a system, which actually sometimes we describe a system using a little cool parenthetical bracket over there. So that says these two lines go together. This is a system. What's strange about it is we have two variables. The first question that should pop into your mind is, how do I solve for variables when there are two of them? Like, who do I isolate? Do I isolate x? Do I isolate y? And if you kind of think ahead, what would happen if you isolated x or y in each of these equations right now is that we'd end up with, let's say, actually, I'll show you as an example. The second equation, I could actually rearrange this by adding 5y to both sides, which would isolate x. I'd get x equals 9 plus 5y. So x is isolated, but have we solved for x? Well, no, because we can't get a number out of this. 9 plus 5y, we can't solve that. We can't simplify it, I should say. It won't come up to a number. So what are we going to do? Well, I'm so glad that you asked that question, because that is what the substitution method is for. The substitution method recognizes that in order to solve equations, we have to eliminate all but one variable. It's not okay to solve for x and y at the same time. We need to come up with a way to solve for either just x or just y. And as it turns out, we've already done the first step of the substitution method, which is solve one equation for one of the variables. So let me write that as a step. Solve one equation for one variable. In this case, I'm like going off the edge there. Whoa! Maybe I'll just say VAR to abbreviate. So solve one equation for one variable. In this case, I've taken the second equation and I've isolated x. So I've said x is equivalent to 9 plus 5y. The second step of the substitution method is to take that value, 9 plus 5y, and plug it in to the other equation. So plug in value of, in this case, x. It could be x or y. Maybe I should say x or y, depending, into other equation. And here's how we do that. We say if x is the same thing, that's what it means to say it's equal. If x is the same thing as 9 plus 5y, then I could actually come to this other equation here. And instead of x, I could replace it with 9 plus 5y. Let's see what happens when I do that. So I'm going to actually use a different color so we can compare. We're going to say 2, not 2x, we're going to say 2 times 9 plus 5y. Now again, if you're like, wait, remind me again, where did I get that? Right here, because we said x is the same as 9 plus 5y, so I'm replacing x, plus 3y, I'm just copying the rest of the first equation, equals 5. So I've just written the first equation in a different way. In fact, I've written the variable x completely out of the equation. Take a look at this. Before we had x and y, now we have just y. That should make you feel good, because we know we can solve for an equation if there's one variable. We just had trouble solving when there were two variables. So using substitution, I was able to basically take one of the variables out of the equation. In this case, I took x away. I substituted a y value for an x value. So step 3 is to now solve for the variable, in this case, y. So let's do that. We're going to distribute the 2. 2 times 9 is 18. 2 times 5y is 10y. And then we have plus 3y equals 5. Let's combine like terms. That would be 10y and 3y. We have 18 plus 13y equals 5. Then we're going to try to get y by itself. So let's subtract 18 from both sides. It's going to leave me with 13y on the left, and it's going to leave me with negative 13 on the right. So divide both sides by 13, I get y equals negative 1. And the question is, have I found my solution yet? The answer is almost, but not quite. The question that we've asked ourselves is, what is the intersection of these 2 points? In order to find an intersection, in order to find the solution, we need an x value and we need a y value. We have the y value. Y is equal to negative 1. We don't have an x value. So let's think, where could I get an x value? Well, take a look at your little equation up here. You said at the beginning, you and I both, said that x is equal to 9 plus 5y. We rewrote it. We know that the value of x will always be the same as 9 plus the corresponding value of y. Well, I have a value of y now. It's negative 1. So we're going to plug it in to find what the corresponding value of x is. So let's use a green so that we can see that. So now we basically solve for other variable. That's going to be the green. Okay, so I just plug it in. I know that y is negative 1. So in my equation up here, I say x equals 9 plus 5 times negative 1, because that's what y is. 9 plus, that would be 9 minus 5. So x equals 9 minus 5, or in other words, x equals 4. We have an x value and we have a y value. That is our answer. And if we want to write it, which I would like us to do, we can write this as a coordinate, xy, right? Just like a normal coordinate point, 4, negative 1. And what does that 4, negative 1 mean? Well, it means if I plot these 2 lines on a graph, let's see, 4, negative 1 is this point right here. If I were to plot these 2 lines, I would get them to intersect. I don't know exactly what they look like, but they would intersect exactly at the point 4, negative 1. Without having to graph and go through all the annoyance of trying to figure out where those lines intersect, which, let's be honest, can be a little bit time-consuming and annoying and take way too much paper, kill way too many trees. Here we can figure it out simply algebraically. Let me review one more time before we'll actually stop this here, and in the next video I'll show you a second substitution example. But before we move on, I want to just review our steps. First step was we solved one of the equations for one of the variables. So we took the second equation here, x minus 5y equals 9. We solved it for x. Second step, we plugged in that value. So x was equal to 9 plus 5y. We took 9 plus 5y and plugged it into the other equation. When we did that, it turned it into an equation that we could solve. So we solved for the variable. And then we used that number to solve for x, for the other variable. All right, make sure you have that written down. We'll have a second example in the next video.